frequency drive. This is different. Up to now, all our control for controlling our starter current has been done through the field windings and controlling the voltage and the current through that way. This one here, what we're doing is we're going to change the frequency. So these are predominantly variable frequency drives, are predominantly motor speed controllers, but they have the benefit of accomplishing starting control as well. So we can start that motor very slowly and ramp it up, get it really smooth running, up nice and smooth and slow over a longer period, and we can really control those huge starting currents. So you can get a motor going so there's no stepped control like we have been doing with all our other starters, using contactors to switch in different levels. So how does it do it? What it does is it brings in our three-phase AC, converts it to DC, so we're rectifying our AC to DC, and once we've got into DC, we invert it back to AC, so we're bringing AC in, changing to DC, and back to AC. But the magic all happens in this last bit, the DC to AC. Because we're building our own AC, we can vary the frequency of that, so we're no longer fixed to our 50 Hertz. So we can alter the frequency to change the speed of the motor. Let's have a look at one. So how do you get them? You generally buy them to suit the motor size, and then you just program them up to suit your task. Have a look at one. Here we go here. Very easy to install. They're generally bottom fed, so what we normally do is we bring our three phases in, our supply, and then just straight out to our motor. All our stops and starts, there'll be terminals in there for them as well, and quite often they're at a low voltage. They might be 5 volts or 12 volts, or maybe 24 volts, so we can run some small cables out and put lots of remote stops and starts in there. And then we program up our starting. We put in our maps, we call them starting maps. We map out how we want our motor to run, program it all up, and it will save it. Not only that, but this can be put on a network, so it can be controlled over a network. It can talk to other motors in the plant. It can talk to maintenance people. It can send signals out. It can receive signals and change parameters as it's driving along. So it makes a very powerful piece of kit. So not only can we control our starting currents, but we can do so much more with it. These were once very expensive, but the price of them are dropping all the time. So a lot of these units are in place and now are taking over our more traditional contactor control, which we've been building up. I'm going to go back and we're going to look at our last current starting control method, which is a slip ring motor. This is an induction motor as well, but the squirrel cage rotor on the inside is a combination of a squirrel cage and windings. So up to now, our induction motors have had no windings on the rotor, which makes it a nice, simple, beautiful motor. Nice and simple, no brushes, no commutators. This one here, we put a winding in our rotor as well, and so we need brushes and commutators. We access that winding so that we can control the current deep down in the rotor of the motor rather than in the field. So we can change the resistance of the rotor so that when it starts, we can have some extra resistance in there so that the currents that builds up in the rotor will be a lot less, and we can switch that resistance in and out, just like our primary resistance starter. But instead of accessing the fields, we're doing this in the rotor of the motor. So it makes it quite complex and high maintenance than our traditional squirrel cage. And you can identify this because it's got brushes and multiple connections. Let's have a look at one here. So here it is. It just looks like a standard induction rotor squirrel cage, but if you look carefully you'll see these windings here as well. We have our traditional field winding, but this has also got rotor windings. Comes out to a commutator, and then brushes come off the commutator out into contacts, which means that we can change, by adding external resistors, we can change the resistance of our rotor here and control our starting current that way. Some of these motors are very large. They might be used in very big kits in a plant where they're doing a lot of work, like a rock crusher or a big cement mixer or something. And when they start them up, they'll start them up slowly with these external resistances. Just like our other starters, once it's up to speed, we do away with it, and we are only really controlling it just at the start, just to manage those starting currents. And that is the last one.